Right. When you double click on data and analysis, you should be getting data and analysis here. It doesn't open anything new. It just takes you to the section of data analysis, which is part of the main screen. It is just you are scrolling down on the same main screen, right? I will do this again. What you do is you select to add a new comparison and you say we are comparing zinc versus placebo, let's say. Whatever name that you have selected should be coming here on top as new. Here there's a problem in my software. It is not appearing. Otherwise that name should be appearing here, right? It should be zinc versus placebo, right? Under the comparisons, you are having outcomes. Under the comparisons, you are having outcomes. Here we are looking at two outcomes: fasting blood sugar, HbA1c, right? So you click here, you are now going to add the outcome fasting blood sugar. What kind of variable is fasting blood sugar? Is it a dichotomous variable? No, it is a continuous variable. Other ones, just ignore for the time being, right? It is a continuous outcome. What it is asking is, what is the type of outcome? Is it a dichotomous outcome? Like what I showed yesterday, remember steroids and death? So it was a number of people. So that kind of thing falls under the dichotomous outcome. Here it is a continuous outcome, fasting blood sugar. So you select continuous, select next. It is asking what is the outcome you are looking at. So you are looking at fasting blood sugar. It is asking what are the two groups. So these group labels will come at the bottom of the forest plot. So here experimental group is zinc. Control group, either you can leave as control or you can say placebo, because sometimes you have to remember there are active controls, right? Sometimes there are active controls. So here you can say placebo. Click next. This is the standard this thing. So here again it is asking analysis model. Don't worry about this screen, because whatever you select now you can change later. Even though you select fixed effects now, once you enter the data, if you feel you need to change to random effects, at a click of a button, you can do that. So don't worry about the contents of this screen. Just click next. Again, don't worry about the contents of this screen. All those can be changed because it is now giving standards. It is asking what are your confidence intervals, the data we are entering, what are the confidence intervals. You know that we generally take the 95 confidence interval, right? So these are selected by default. But even though you select, if you want to change this later, it is can be done by a click of a button. You don't have to worry, right? Again, here it is asking how to sort the studies, right? We sort the studies by study ID generally, where it is in the alphabetical order. If you remember the forest plot that I showed you, of course you can sort the studies by many things. Where you, if you want, you can, the studies that are having the highest reduction in blood sugar can come on top. So that is if you sort by the effect size. Here, if you sort by study ID, that means it will be in the alphabetical order, right? Okay. Once you click next, and when you click finish here, you will be taken to a screen like this. Are you at this screen? You can take your time. So here it opens a new window. Now remember, this is the old window. Here there is another window. It opens a new window where the outcome name should be there. Again, I told you there's a problem in my software, but otherwise fasting blood sugar should be coming here, the name that we have given. So on one side, you have zinc. On the other side, you have placebo. This is where you enter the data, right? On here, you have the studies. At the moment, you can see it is blank because we have not included any studies in this analysis. We have included studies for the main article, but we have not included all the studies here, right? Now, the important difference there is not all the studies may be reporting all the outcomes. Now, if you take these three studies, maybe two studies are only reporting HbA1c, right? So all the studies we have included into the main body of the article doesn't automatically come here. That is why, right? You are given the freedom to select the articles you want to include under each and every outcome, because all studies included in the meta-analysis may not be reporting all the outcomes you are looking at, right? That is the reason, right? So here, now you have to manually include the articles by clicking this plus sign. Can you see the plus sign here? Can you see the plus sign? I hope you are following me, right? When you
Yes, we can
click
see.
on the plus sign, or you will be taken to a window like this, right? Where you will see now the studies that you have put in the same names that you have put. So you can select from this for fasting blood sugar, what are the studies I want to include in the forest plot. Maybe all three articles are requiring reporting fasting blood sugar. Maybe only these two are reporting fasting blood sugar. So you can select. Once you click on that, you can add one by one, or press shift and press the down arrow key and select all. And when you click finish, it adds the articles here. Can you see now? Now the articles are there and the data entry points have appeared here. See? Data entry points have appeared here. Right? Now we are going to enter data. You need your table now. So what do you think is the mean that comes here? It is asking for the mean in the zinc arm. What is the mean? Zinc arm has two means, pre and a post. So what is the mean value that comes here? Anyone? Anyone? So I will show you. Now it is asking us to enter the mean value. So what do you think? Is it the post mean only? So then what will happen to the pre-value? The mean value that is entered here is the mean difference. Now keep that in mind. It is the post minus pre, the mean difference that we calculated. So what is the mean difference? If I remember right, so you can enter the data here. So important thing to remember is to never forget, if it is minus, you need to enter the minus sign. So it is minus 16.1 if I remember, the mean difference, post minus pre. Now here you have a problem. Here it is asking for the standard deviation. How do we get the standard deviation? Let's quickly go back to the table, right? Let's quickly go back to, yes, it is the mean difference you are entering. Somebody has asked. I will share the screen once again, right? Let's quickly go back to the table. So the mean difference is 16.1. We entered that. But now the software is asking, what is the standard deviation of the mean difference? Can we simply deduct 57.81 minus 64 and get the difference, the standard deviation for the mean difference? No, that is mathematically wrong. You can't do that. You cannot minus a standard deviation from another standard deviation. What is the solution? But now see the practical problems that come. The important thing that I want to show to you is that when you are reporting data in your primary studies, let's say you are the author of this study, right? Remember to report these key data which are required for meta-analysis. Otherwise, the authors that are doing meta-analysis might contact you by email and ask you for this. But if you don't reply, they might exclude your article from the meta-analysis. Now, see the importance of reporting key data in your primary article. Here, the primary article doesn't contain the key information about standard deviation. Is there a solution to this? Yes, there is, right? So we will go back to the software. We will go back to the software. I'll share the screen once again. Right, okay. Can you, so you select this particular study, right? Can you see that there is a small calculator sign here? Click on the calculator, right? It will take you to a window like this. Now it is asking, okay, the number also we didn't enter, but the number is still here. We can enter it. If you want, you can enter the number here. Number means the number of people in that group. If I remember, this particular group had 20. Now, without the SD, we are still stuck. Right? Luckily for us, this particular author has given to us the p-value. The p-value of the difference between the post and the pre. If I remember, it was 0.09. If you enter that value, the software will automatically calculate the rest of it. Now can you see? This is autofilled. So the p-value is a key data that you need to extract. What is the p-value you need to extract? You need to extract the p-value for each group pre compared to post, or post compared to pre, whatever, because remember, because some authors report p-values comparing these two groups. That is not what we want. We want in the same group pre versus post p-value comparison, right? Luckily in this study, the author has reported that. So without the SD difference, we were able to calculate the rest of the values. Same problem is there for the placebo group. So we will enter the data. Now you will see, right? I will go back. I can't remember the values. 1.9. Okay. 1.9. So follow me and enter the data. Again, the ST is not there, but luckily for us, we have the p-value. So you enter 0.55. Everything is filled now. You click update the table, it automatically updates the table, and on your right hand side, it now is starting to generate the forest plot. You can see one study is there, total value is there, but obviously a total value is the same as this because we only have one study. Now, can I ask you a question? How many studies do you need to do a meta-analysis? How many studies do you think that you need to do a meta-analysis? Yeah, at least 2. The answer is 2. You only need 2 studies to do a meta-analysis, but that is not going to be a good meta-analysis because if you have only 2, unless they are homogeneous and they have the same values, I-squared value is going to be very high. You are not going to get a valid conclusion. But theoretically, you need only 2 studies to conduct a meta-analysis. Theoretically, right? Okay. Right. So now you have a problem in the next article. This is where I told you where you need statistical help. Right? We will go back to the screen again to the Excel, the PowerPoint table. Now in the next article, this author has not reported the SD and this author has not reported the p-value, if I am correct. These p-values I have calculated by a different method, which is not correct, but this is the problem that we have. The authors have not reported the p-value. Authors have not reported the standard deviation of the mean difference. Then you are in trouble. Right? Then you are in trouble. Do you need to exclude those articles? No, you don't, because I will show you, I will take you quickly to the web, right? So you can add this data and see you will get a pool value. Before coming to that, now I'm just trying to show you how you can overcome this problem. This is a little bit of an advanced statistics. Before doing any of this, you should be familiar with data extraction and data entry into Rev-Man, right? So I will share the screen again. Coming on to, yeah. You should be able to see this particular screen where when you don't have data, what we call missing data, you have several options. Number one, you can write to the author and ask, look here, we don't have the p-value, we don't have the standard deviation of the mean difference. Can you send us those data? Most of the time, the authors do not reply. Authors do not reply, right? Second option in meta-analysis is then, see, this is where you need a statistician. you can impute the data. This is called data imputation. Data imputation, whereby using, don't read this now, just know that the principle, right? You can calculate the missing standard deviation using this formula. You can calculate now the missing standard deviation is the standard deviation of the difference for the second study. You can calculate that based on this formula. This is called data imputation, right? That is unfortunately if the authors have not reported adequate data. So the message here for you as researchers who are doing primary research, you need to report adequate data, which is adequate for meta-analysis, right? Otherwise, they might not include your article. You will not get enough citations. They might exclude saying data is not available and so on, right? So keep this in mind. I will share this link on the chat. For those who are, I know that there is a diverse group here. Some may be familiar with statistics. For those who are familiar with statistics, you can read this. Others, just forget about this. Just know that there is something called data imputation when data is missing during a meta-analysis. Remember, on the first day I told you, you need a good statistician if that is the case, right? And the other thing about this is this particular article, this particular thing I have got from the Cochrane handbook. So you can see if you go to the top part of this link, it is published by the Cochrane. There are many chapters on different concepts about what everything I have told you is there in the Cochrane handbook. So that is a good reference software for you to learn. If you are a self-learner, if you can read and learn, it is a good software starting from beginners to advanced like these methods. Everything is nicely detailed out, right? Okay, we will go back to the this thing screen. I will share this link via the chat to everyone, right? Okay, now let's go back to the Rev-Man software. Were you able to enter data for 1 or 2 studies? Did anyone encounter any problems? So you can drag these. If you are not seeing the full summary table, you can drag this here, and now you will see. See, it is the zinc group is on this side, placebo groups in this side. At the moment, we have only one study, so that has been given 100% of the weight, and we are using a fixed effect. You see here this particular button that I told you, by clicking a button you can change. So when you click this button, it immediately changes to random effects. Very easy. When you click this button back again, it changes back to fixed effect. Random effects, fixed effects. Let's enter one more study quickly, right? Because we are going ahead of beyond time. And then I will show you the I-squared values and all that. Just use the p-values I have put in this table. I will answer this question after entering this second study. 1 minute. So the second study, the mean difference is 3.06. 3.06. The n is 18. Standard deviation is not given, so we have to go by the. Now these p-values are not accurate. Huh? I have derived from a different method, so don't ignore that. Now you will see some of these studies actually reported fasting blood sugar as millimoles per deciliter, where you would have had to convert. Now because we are reporting now as milligrams per deciliter. So again, an important thing that you have to remember, right? So you update the table. Now you have 2 studies, right? And you have a summary estimate, right? If you want to see the full forest plot without this table, with the like the output that we got, you can click on this button. Can you see? When you click on this button, you get the table that I was describing to you. Nice table where the studies are there. The value, the third study we have not entered data yet, so it has not been included in the final estimate, but the other studies are there. Right? It says the model that we are using, fixed effects, right? It says the summary statistics. It will tell you the I-squared value, which is 0, which is very good. That means the heterogeneity is very minimal. But however, the overall effect is not significant. P-value is 0.06, right? 0.06. It should be less than 0.05. Can you directly export this? Yes, you can save this as a, when you click on save, you can save it as a graphic file, PNG, PDF, or whatever format that you want, which can then be incorporated into your article, right? Can you look at the funnel plot here? Yes, funnel plot is this one. See, it will generate a funnel plot like this. So that also you can save as a file and then include in your article, right? Save as a file and include in your article. So you can input further data. So you need more studies. This is not a very accurate representation. One more thing that I wanted to show you is the Cochrane's risk of bias assessment tool. Before that is the last part we will do for today. So before going for that, any questions on this part so far? I know there is one question in chat. I will look at that and answer. Any other questions? How can we decide the unit for summary effect size? That is again up to the authors to decide. It doesn't make a difference as long as the same units are used in all the studies. So because finally in this study, our conclusion will be zinc reduces fasting blood sugar by 16 milligrams per deciliter. If you have used millimoles, you can report it as millimoles as well. That doesn't make a difference as long as you have used the same unit for all the studies, right? Any questions so far? I know this is a very difficult area, right? Because you are doing this for the first time, right? I did this for the first time in 2012. So it has taken me 8 years to come to where I am. I'm still learning about the different methods, right? What do you mean units are different? In the same study, it will be the same units. So you can convert. Millimoles per milliliter can be converted to milligrams per deciliter. Yes, there is a question. Can you elaborate meaning of weight? Yeah, the weight in the forest plot is what is used to calculate the okay. Yes, Karthipan, you need to do a conversion if the units are different. Yes, yeah, correct. So the weight here is allocated depending on the model. Now here you can see the weight is in the fixed effect model. The weight is allocated depending basically on the sample size. The study with the highest sample size and the lowest variance. Now here you can see this study has the lowest confidence interval. That is given more weight. Studies with the lower sample size and higher variance, higher the confidence interval means lesser the precision. Those studies are given lesser weight. Those studies are given lesser weight. So that is depending on the model, the weightage is decided by the software. The weightage is decided by the software, right? Any other questions? I will quickly show you one thing. You can think further and ask me questions. Remember I told you on the first day that Cochrane also has his risk of bias assessment tool. This is here. If you go to the left-hand menu and click this, differences between protocol and review and publish notes. If you click on publish notes, you are brought somewhere here. So you see the first study that we have included. Under that, there is something called risk of bias table. The author, the reviewers or the people who are doing the systematic review can decide, is the random sequence generation appropriate? Then the bias is low. Is the allocation concealed? So this is not a scale where you give points. The authors have to decide whether the risk of bias is high, low, or not clear. So you can give values to this: high, low, high. Let's say I'm doing randomly. I'm not looking at what this is. So you have to read the article and decide, right? Once you mark these, right? So I have entered the data for the first study. Similarly, if you go down the line, further down, you will see the second study also. You can enter the data. Risk of bias table is there. For the third study also, there will be a risk of bias table, right? So once you enter the data and when you come here, you will see here, right now, here there is a button. where you can include the risk of bias also into the forest plot. Once you click that button, the risk of bias data that you have entered for each, these are the individual questions that I answered. So that gets a color. If it is low risk, it gets a green color. If it is high risk, it gets a red color. Now once you generate the forest plot, you can see nicely. See, in the forest plot itself, on the right hand side, you will see the risk of bias of individual studies. Each and every study, according to your judgment, the risk of bias will appear. Right? Okay. And it gives the meaning of A, B, C, D, and these are the different questions. It gives a summary of those questions here as a legend in the forest plot itself. Right? So this is a nice addition to the forest plot, which can be done in the software itself. Right? Only thing is, for individual studies, you need to decide and give the risk of bias, whether it is low, unclear, or high. Right? No, these are different. Yes, there is a question. We will go back to this. No, they look at different types of bias, right? Random sequence generation, selection bias, and then allocation concealment coming under selection bias, blinding coming under performance bias. So they look at different types of bias in the different questions, right? Selective reporting, they look at in the reporting bias. So there are different types of bias that are here. You are supposed to give answers to each and every question, right? Any questions so far? Any questions? We'll be finishing now, because now what I have showed you today is a very, very basic introduction, because I told you at the outset, this is something we do for a full day, right? Generally, Professor Anil Jayawardena does the systematic review part on one full day. I do meta-analysis on a one full day, right? So today I am squeezing, this time I am squeezing everything into 2 hours, right? So I apologize if it was not unclear, but I have tried to keep it very, very basic so that you will understand. But if you do this practically and try it out, and then reach out to me with the questions, I will be happy to help for those who don't understand.
May I ask you a question?
Yes, yes.
Okay. So in an article describing multiple interventional groups, such as in article number 2 and 3,
correct.
For example, one group is given only minerals, other group minerals plus vitamin.
Correct.
So if we find out the mean value for the fasting blood glucose pre and post, then the post mean those two groups, two groups with minerals and
correct. I understand your question. What you are asking is, are we only selecting the minerals group? Are we only selecting the minerals and the vitamins group? Or are we combining them and including?
Yes. That's correct? My question.
Yes. Yeah. So that is again up to the group of experts to decide. If the experts decide, okay, we are going to include both groups, but separately, you can include them as two studies. Let's say FAVIT 2005A will be the mineral group. You can include another study here. Under included study, you can include another one saying FAVIT 2005B, where you include the minerals and the vitamin group. That is option number 1. Let's say you want to combine the two. You go here, you click this, and here you can combine the two values. Can you see that? You can combine multiple groups. You select let's say in this particular article, there are 4 groups. You want to combine all 4. Click on the calculator. You can see a calculator sign here. Click on that. You can combine these groups. You can even add multiple groups. You can go on adding, right? But the problem you will encounter is you will need then the standard deviation for these groups, which then if they are not reported, you will have to do a data imputation, right? Okay. That is something you have to keep in mind.
Thank you.
We will look at other questions. When did one article report a particular outcome at a different time? Again, the same thing, where you either include both 3 and 6 months, where you include the 3-month data, let's say as 2005, or where you include the 6 months data as 2005A and 2005B, or you combine, or you decide we are ignoring the 3 months, we are reporting 6 months outcome. All of these you have to mention in the method section. Now you will understand why we are always talking about a group of experts getting together, right? You will decide, okay, most of the articles in my review have looked at beyond 6 months. So then in this particular article, I will ignore the 3 months and I will take the 6 months, so that the studies we are including are uniform, right? So that is where the inputs, the value of the set of experts come in, right? And that is where the subjectivity comes in. Subjectivity comes in, right? Okay, there's another question. Yeah, in a crossover study, let's say the crossover study means the same group crossing over to the other group. Ideally, they will be reporting before starting the second phase, the mean value. You have to always take the mean value before the intervention and after the intervention. If those are not reported, you have to contact the authors and get those values.